All right, so now that you've understood what blockchain technology is, so I think it's also right for us to understand what we mean by transactions and distributed ledger. So these are key terminologies that you really need to understand if you want to really get it right within the blockchain technology. So transaction and a ledger, these are closely related terms that more often you'll always use them when you're talking about blockchain technology. But first, it's important to understand ideally what is a block and of course what is a transaction, right? Uh, Take an example of a folder, all right? A folder can be seen as a block, right? Then the files that you place within that particular folder can be seen as transactions, right? So a block comprises of multiple transactions, right? So what is a transaction? Transactions are a series of values that are executed, right? It could be some transfer of money, right? It could be someone is initiating maybe a particular transaction from point A to point B, right? So the most important thing to understand is that at all transactions are logged, right? Including information about the time, a date, a participants. Ideally, this transaction constitutes a lot of information, right? And of course, this particular transaction are performed in individual or respective nodes. And as you have already mentioned, one key feature of a blockchain technology is to be able to distribute these particular transactions. So you realize that each and every participating node within a blockchain will really have a full copy, right, of that particular blockchain transactions that have happened, right? So it's very, very important to understand that every node must execute some series of transactions which are stored in block format. So also need to understand how do we carry out these particular maybe transactions, or how are transactions formed, right? As you can see from this particular diagram, at this particular point, right, all transactions are initiated, right? Yeah, so you can always create these particular transactions, and you can see they are stored in this particular block. So this block comprises of different transactions, the way we have already mentioned, right? So you can have a single block comprising of multiple transactions, right? And these particular transactions, there are different processes that needs to be done on them. Like for example, the transactions need to be validated, they need to be linked to other transactions on a different block. So that's why you normally have transactions before a block. A block, we can't have a block without having transaction. Actually, the end game is to consolidate all these transactions so that you can have a block, and that's what we are seeing here. Now, the other step is to verify, or rather carry out some kind of consensus, and we are going to look at this in future. So we have some kind of consensus algorithms like proof of work, right, and all that. So you can see here there are always some issues maybe when it comes to validating these particular transactions or other blocks. So there could be some consensus that a particular block should be formed, or if it's not valid, then they can always stop this particular creating of blocks and create another block. So here is where normally you will get the term forking, right? Creating of a different chain of blocks. But today we just want to understand about what this particular block and transactions mean. Someone will ask, can we change the transactions within a particular block? I mean, generally, when you talk about validating or rather applying security within these particular transactions, there are a lot of features or security features that are normally applied. Like for example, when a particular block is being validated, they must ensure that first their digital signatures appended, they have public keys, what we refer to as cryptography. So it's very, very hard, actually, to crack the details within a block, right? But for the individual transactions, you can always do that as long as you can convince, if it's a node, it can convince 50 plus 1 other nodes that they need to share the various cryptography details, which is actually very, very hard. And that leads us in understanding also another terminology, and that is a ledger, right? A ledger is actually like an open book that records the different transactions. When you talk about blockchain as a distributed system, then we need to understand that these particular ledgers need also to be distributed. We have also seen that transactions are actually applied or replicated in different nodes. So that means this particular replication of transactions allows also the blockchain to have this particular distributed ledger. So when you talk about a ledger being immutable, that means you can always not really change this particular information, right? So ideally, it's very, very hard to hack a block of these particular transactions or other ledgers. That's why we normally use the term immutable, right? So as you can see, we talk about distributed immutable, right? So this concept of immutable means that all these ledgers cannot be easily edited, or rather you can't interfere with the contents of this particular ledgers, right? So ledgers, as I'd mentioned, we can also have very many copies of transactions, right, that forms a ledger. Now, a ledger can be seen as a database that stores, again, these particular transactions within a block, right? So as the nodes do the transactions, they keep a copy of the ledger, which actually becomes distributed. This concept of distributed ledger, we are going to look at it a little bit later and see what's the difference between a distributed ledger and, of course, a distributed database. So as I've said, transactions are actually transfer of values, right? So you can initiate a particular transaction, be it could be transfer of some money from one point to the other, right? Then, as you've already also mentioned, a block is a collection of transactions, right? So you see where the difference comes in. And with respect to the application of Bitcoin, right? So this one we can always say. Now, this particular diagram, we have like 3 blocks here. And these 3 blocks comprises of different transactions, right? As you can see, the bottom part, right, shows the different transactions, right? So when we link the different chains of blocks, you can always have what we refer to as the proof of work. So before a node validates and create a new block, there should be some consensus. So what you're seeing here as a proof of work is some kind of consensus algorithm that has to be reached. And below here you see previous block. These are a set of hash values. Hash values are there to ensure that there's some chains. Actually, it's what brings on the chain term, right? So every block after it has been created, there must be some hash. Hash is like the final stamp that is placed within a particular block before forming another one. So I hope it is now very clear what transactions are, or how transactions are created and what blocks are. Now, we also need to understand how transactions are actually validated and created. You are aware that, for instance, in Bitcoin world, people normally mine Bitcoins. Now, if we have some set of nodes, like for example, these ticked areas, we can talk about them as nodes, right? Now, we have nodes that are more powerful than the others, right? Maybe with respect to additional rights. These nodes are normally referred to as miners. Now, miners are some kind of sophisticated computers, or rather nodes in a particular blockchain that has the capability of solving complex math problems or computation. And in fact, when miners are actually validating these particular transactions and blocks, it kind of takes some kind of time, right? So they should be very powerful. So if it's a computer that is mining bitcoins, for example, they are normally very, very powerful computers, right? So it's a continuous process of validating. And normally, when you have 2 or 3 miners in a chain or in a blockchain, the first miner to get the right computation or to validate a particular block is normally rewarded. So it takes some kind of powerful computation process for miners to be able to validate these particular transactions, right? So that at least they create a new set of block. So if there's some kind of errors, there's some kind of issues when it comes to validation of this particular transactions, then all the participating nodes are not going to come into a consensus. So normally that chain or that particular block is not going to be formed, or there could be a parallel chain of blocks that are going to be formed. That is what we are going to look at, known as the forking. So yes, miners play a very, very important role, and they should be actually powerful systems that can be able to compute heavy or complex mathematics. Let's look at it practically. So what I was saying, as you can see this particular diagram, as you can see, it allows us to understand how transactions are formed. So we have told here that there's some kind of Bitcoin transaction that needs to happen. So this is James. So James here wants to send some 500 Bitcoins to Kevin. So that is a particular transaction that has been initiated. And you can see these transactions are captured, right, in a ledger form. So this is a centralized ledger, right, in the middle here. This is a centralized ledger that carries the copy of this particular transaction. So when you have centralized ledger, that means the other participating people are not going to see or have this particular copy of what? What this particular transaction that is happening. So that means there could be a problem with this, and that's what blockchain technology normally tries to eradicate, right? Because it's only Kevin right now and James who can be able to see this particular transaction. So until everyone has a copy of this particular transaction, then we can say we are talking about distributed ledger. Now again, we have also the miners here. I can say we have Lisa as one of the miners, and also we have Robert, right? So when James initiates a transaction, miners such as Lisa and Robert are going to be alert, and they will start looking at the past transactions from Kevin and from James. Let's say, for example, Lisa is going to check the amount of Bitcoins that James has, because he wants to transfer 500. So they want to see if maybe James has the amount, or is he able to do that particular transaction, right? That is the work of miners. They are the ones to see if this particular transaction is possible or not. So once they ascertain that he can be able to send this particular amount of money, or rather Bitcoins, they'll start now digging into their past activities. So they want to check maybe the right key so that they can validate this particular transaction, right? So that's what the role of Lisa and Robert is. So on the other end, you can say what this particular transaction entails, right? So it captures maybe the balance, it captures the amount that was maybe transferred at a particular time, and you can see the account numbers that are being recorded. So this is just a sample ledger, right, that comprises of different transactions, right? So every transaction holds details of the transfer of currency, right? And you can see after every block has been validated, it keeps on growing from this particular diagram. So you can see there's a hanging block here. Now this hanging block simply means it is in the process of being validated. So once it meets consensus or the criteria that is required, it's going to be appended to the next block. So a given anatomy of block, as I'd mentioned, it captures a lot of details. A block has a lot of details. It captures the hashes that has been performed, the bits, the version, the reward. So what I was talking about this, so you can see the reward that has been given here, 25 Bitcoin. So this is kind of a block from a miner. So if a miner successfully validates a particular ledger or some set of transactions, then they are normally rewarded, right? And you can see the receive time. So someone might ask you, maybe what are some of the information that a block consists of? So it consists of the number of transactions that have been done, volume of the transaction, ideally the transaction fees, and so on. So you can see here, once this particular, once the transaction or the block has been validated, so you can see now the miner here, it is Lisa who got the validation first, as you can see, this particular check. So James can now go proceed and do what? And send this particular money to Kevin, right? So this particular procedure of validating this particular transaction before it happens, it solves quite a number of problems. The first one, ideally, it improves security, right? It improves security so that not maybe every participating node should be able to know what are the primary, what are the public keys and the digital signatures that were used initially to create this particular transaction, right? The other end, it also solves the problems of double spending. Double spending simply means James cannot be able to send amount of some amount of Bitcoin that he doesn't have, right? Or he cannot simultaneously send different amounts of Bitcoins that are not available within his account. So it actually improves on the features that this particular blockchain technology provides. So as you can see, this is how transactions happen, and of course how they are validated. Now, when a particular node or other user wants to start a transaction, what they normally do is to broadcast that particular request. So what happens is that an initiation, or when they initiate a particular request, every participating node, so if there are 20 nodes in that particular blockchain, they need to know that computer A or node A is wants to send maybe some amount of Bitcoins. So they become alert, right? And that's where the participating miners are going to maybe see whether they can be able to accept that particular request, validate it, right? And as you can see, the validation happens after the broadcast has been done, right? So verification also happens here. So the new block is actually appended after it has been validated, right? And you can see the transaction becomes complete. So it's just a chain of events or processes. So it's not something that you just say that I want to initiate this particular transaction and it should go through, right? So there are a lot of validation process that needs to take place. So a typical example, when a particular or participating nodes within a peer-to-peer network, when you want to, for example, initiate a transaction, you can say here, computer A here, right? There's an example here. So suppose A finds the transaction, right? Bobby pays 5 coins to Cindy. This we have already looked at this, right? Node A broadcasts to peers So there's kind of broadcast. Peers are these participating nodes. So remember, a blockchain is implemented on top of a peer-to-peer network. So all these computers are equal. So if the transaction is verified, the peers here, like B and C, will forward the transaction to other peers. So it's kind of just a broadcasting process, right? So all peers must have, before validation happens, all peers must have the copy of this particular transaction, right? So it normally happens very, very fast. So if there are more than 1,000 computers, for instance, they'll have that particular copy, and they'll have to reach into a consensus that this particular transaction or this particular block needs to be added to the chain of block. So as we have already mentioned, the term ledger here normally just refers to the consolidated series of values, or rather transactions that have been performed. We talk about distributed ledger. That means every node or every computer must have a copy of this particular ledger. So as you can see, the first one, this is what is eradicated when you talk about blockchain. So this centralized ledger is not applicable when you talk about blockchain technology. But for the distributed ledger, we normally give it a tick, because this is what is implemented in a blockchain technology, and it has additional benefits compared to centralized ledger. Maybe you can look at the pros and cons. For example, for the centralized ledger, you can see there's a third party involved, that is the bank. So before client A sends money to client D, bank will do some kind of maybe or apply some transaction cost, so it's actually expensive. Ideally, to move money from point A to point B, it could take some time, maybe 3 days or 2 days, compared to distributed ledger where it happens very, very fast. We have also seen the issue of double spending. So it also eradicates the issue of a particular node sending, for instance, bitcoins that they don't have, right? And security also is an issue here. Someone can decide to hack the bank and all the money can get lost, right? So when you look at the distributed system here, it does away with this centralized or third party kind of arrangement. So every node here has a copy of the transaction that is happening, right? So if one node fails, for example, the other nodes can be able to provide the evidence. It's very, very fast actually to actualize, or rather transfer money, or rather bitcoins, from one point to the other. Maximum maybe, let's say, 10 to 12 minutes, right? Because of the computation, right? So ideally, there are a lot of advantages that the distributed ledger brings on board. Now, we also talk about different applications, or rather implementation of distributed ledger. And this one will help us understand the multiple types of blockchains that we have. Like if you implement a single entity, a ledger, that means you are implementing a private blockchain, for example. This one normally happens within a single organization, right? Or what we refer to as a centralized kind of a system. So if you have like Bank X, let's say Bank X. So if Bank X want to implement a distributed ledger, so they'll have a kind of a simple blockchain only for that particular bank. And that's why we say it's a single entity ledger. What about multiple entities? So here we have Bank A, right? We have Bank B, and also maybe we have Bank C. Now, if all these banks decides to implement a particular blockchain, maybe just to facilitate all these banking processes, then we say they are implementing a distributed ledger across multiple entities. So all these are distributed ledger, but how they are implemented. Now, what is these multiple entities, right? So these multiple entities brings on board the private blockchain and the public blockchain. So we can talk about these as a typical hybrid blockchain that is being implemented, right? So how is a distributed ledger formed, or how does it work? We have so far looked at how the transactions are created. So this is just a wrap up. So first, the user broadcasts or initiates the transactions, as you can see, using their digital signatures. So you need to have some set of security appended on this particular transaction. And of course, they replicate, or rather they broadcast these particular transactions to the various nodes, right? So ideally it's the work of the node that has received this particular broadcast first to replicate it so that every participating node gets a copy of this particular ledger, right? So once they have a copy, they now start validating each transaction. So every node starts validating, but we talked about miners here, right? So miners are given the upper hand of actually having us the final say or the validation process, right? So here also they do some kind of, they aggregate the validation, right? And form some kind of block, right? So they consolidate kind of this particular validations, right? So if that happens, they accept, and the validation is again shared, right, across these multiple nodes. So they broadcast again so that each node can maybe come into terms, and the consensus algorithm here is used, right? There are quite a number of algorithms, so it could be proof of work. So once a consensus has been arrived at, then the new block is actually formed, right? The new block is appended to the chain of blocks. So these are must understand how the ledgers are formed or how the distributed ledgers work. Someone might also ask you how are transactions are validated. So this is the approach that normally is used, right? So a typical scenario that I've already mentioned, when copies, or rather when transactions are made, right? Let's say here we have, this is just an open ledger. So it's just a single copy, as you can see in the middle here, right? So when Andy, for example, wants to send $5 to Bobby, see the Andy has at least $10, so that means he can be able to do that, right? So this transaction starts to capture, so this is a ledger, it starts to capture all the transactions that are performed, right? So Bob also wants to send $3, and Darby also wants to send $1. So it could be just a process, and this process of transactions, or creating of transactions, are captured in this particular ledger. So this is kind of a centralized ledger, right? But the best approach is to have a distributed ledger, right? Distributed ledger, where every person is going to have a copy of this particular ledger. So you can say we totally eradicate this particular centralized way of capturing the transactions, and distributed ledger, or rather distributed system, allows us to have, or all the participating nodes or individuals to have a copy of this particular ledger. So these are typical transaction within a blockchain system, right? Again, we need to to have a clear distinction between what a database is and what a blockchain ledgers are. Actually, there are quite a number of differences, so that someone might not really say, why do we need a blockchain and we have already a database, right? First, it begins with the architecture. How a database is implemented is actually very, very different. For you to form, for example, transaction within a database, it takes a lot of process, right? You need to append a lot of details there, right? So a database, as you can see, right, there's quite a number. We need to have maybe a client sending or updating this particular database. Then you need to have the server that has to accept the request to update the same database. So you realize that now the database, for it to function properly, it uses the client-server architecture. Whereas for the blockchain, all the participating nodes are equal, the peer-to-peer, right? So for the ledgers that are created, there's a peer-to-peer. This is what is shown here, right? Like all the participating nodes are equal. But for the database, you need to have some kind of centralized server. So that's one of the major difference. Other difference, as you can see, for the databases, they must have admin control. For blockchains, they don't have admin control. Databases have entities with the right to access. For the blockchains, especially the public blockchains, anyone can access. Databases are fast, I agree with that, whereas blockchains are slow. So normally blockchains are slow based on what you have seen. Yeah, they need to reach at a consensus. They need to perform thorough validation. That maybe makes them a little bit slow. For database, once you move the transaction, that is it, right? No history of records within the databases. For the blockchains, the kind of history of records and ownership. So that is it when it comes to the differences between databases and blockchain ledgers. So going forward, we need to understand then how we can reach into a consensus when these particular blockchains are created. So in our next set of tutorials, we are going to mention how this particular consensus algorithm works. All right, thanks.